in this video, we are going to talk about finding quotients with benchmark fractions. So, when we say quotients, right up here, this vocabulary word, quotients, that's the answer to a division problem. So it's the answer for division. And if you want to add this to your notes, that would be a smart thing to do. So what we're going to do is we're going to use our knowledge of benchmark fractions whenever your divisor is 2, 3, 4, 5, 6, 8, or 10. And this is a really, really great way for you to save a little bit of time. So we have our quotient right here, and in this problem, 16 divided by 5, 3 is the quotient, 3 is the answer. I went ahead and I did that one for you already. 5 right here is the divisor. And 16 is the dividend. You'll want to know those words because I'm going to refer to them later on. And you'll want to know, like, oh, I know what that word means. So if you haven't written it in your notes, you should be doing that right this minute. When we talk about division, we talk about dividing something into equal-sized groups. So if we have 16 divided by 5, we can think of that as 16 divided into 5 groups. We can also think of that as 16 divided into groups that are the size of 5. And we have 3 different ways that we can write our answer. We can do it using a remainder. Okay, so a remainder. We can do it using a fraction, and we can use it with a decimal. So those are 3 different ways that we can look at it. So let's start by going over this division problem. And we're going to talk about how we can get those 3 different answers. So we have 16 divided by 5. 5 doesn't go into 1, okay? It goes into 0 times. But 5 does go into 16, and it goes in 3 times. I'll erase that just so we don't think that it's a decimal point there. 5 times 3 is 15. And then when we find the difference between 16 and 15, we get 1 as our answer. Okay? So that's just long division, and you guys have been doing that for a little while, but maybe need a refresher today. So one way we can write our answer is 3 with 1 left over. And we might use remainders when we have things that cannot be cut up into pieces. So we have a situation that says there are 16 balloons that you are going to divide between 5 people. How many balloons does each person get? Well, each person gets 3 balloons with 1 left over. Because you can't cut balloons in half. How disappointing would it be to, like, well, here's your, like, little piece of balloon. Like, you can't break a balloon into pieces. That'd be cool. What now? That'd be cool. If we could. Yeah, I don't know how we would do that. The other way that we can think about it is as a fraction. So we can also say 3 1/5. And we might do that if we're dealing with something like food. So if there are 16 brownies, and we divide them between 5 people, each person gets 3 brownies, but we have 1 brownie left over. And I don't know about you guys, but if there's another brownie left over, I'm going to want it. So we're going to take that, and we're going to divide it between those 5 people. So we have 3 1/5. Looking at our algorithm over here, I'm going to show you how we got that. We have 3, and then we have 1/5. This 1 piece divided between 5 people, so we have 3 1/5. Okay? Now, the last way that we can report our answer is as a decimal. And today we're not going to get in too much with being able to describe how to go from a fraction to a decimal. So I have this chart over here for you to help you. Okay? But if we take, if I find 1/5 on our chart over here, it is equivalent to 0.2 or 2/10. So as you're working on some of your problems today, feel free to check this chart out. If that's something that you feel really comfortable with, awesome, you don't need the chart, but it's something that we're going to work on this year, okay? And then eventually you'll want to have memorized. So what questions can I answer so far? Cool. Let's scroll down just a little bit. And we're going to do practice problem number 1 together. So we have 121 divided by 5, okay? We can think of it as maybe, I don't know, 121 Skittles divided between 5 people. Actually, I'm going to. So, to set it up, we have our dividend, and 5 is our divisor. And notice how it looks a little bit different when we set it up as an algorithm. So that then 5 comes first, you're dividing 121 right here by 5. So just so we know how it looks when we set it up. Okay. So 5 does not go into 1, but 5 does go into 12 2 times, because we have 5, 10. 5 times 2 is 10. The difference between those two, between 12 and 10, is 2. Then I'm going to bring down my 1, so I now have 21. 5 goes into 21 4 times, because 5 times 4 is 20. I'm going to find the difference, and I have 1 left over. Okay, so the 3 ways I can write my problem. I can say that my answer is 24 remainder 1. That's one way I can say it. I can also write it in fraction form. And I can say 24, and I'll show you how I got each of these. 24 and 1/5. And the last way I can do it, 1/5 is equivalent to 0.02, 2/10. 24 and 2/10. And this is like a shortcut to know your conversions between fractions and decimals so that you don't have to continue to divide it in this case. Okay? What questions do you guys have? Yeah.
Are we going to be doing really big numbers today, thousands?
Everything will look kind of like this, but we will go into the thousands a little bit. Okay. So let's go ahead and let's work on this part. You guys can keep going, and I'll be around to help you. All right? Okay, you guys can get started.
Find the quotient.
Okay. So, looking at number 3 down here, I'm going to go through just the steps for long division. So if you're feeling a little bit shaky about that, listen carefully. So 2 goes into 8. How many times, everybody? 4. Whew, you got it. So I'm going to put my 4 up here. And then 2 times 4 is 8. So I put my 8 down there. I'm going to subtract. I have 0. Bring down my 7. How many times does 2 go into 7? Everybody?
3.
3. What's 2 times 3?
6.
6. So I'm going to put my 6 here, subtract, and I have 1 left over. So my quotient is 43 with a remainder of 1. my answer in fraction form is going to be 43 and 1/2. Here's where I got the 1. Here's where I got the 2 for the half. Now this is one that you probably already know that you don't even need to look at our chart for. 43 and a half, that's the same as 43 and 5/10. So there's your answer for number 3, all right? So we're going to talk about situations when the divisor, we're now on that 4th page, when the divisor is not a whole number. So that means it's in between numbers. And what we can do is we can rewrite our problem using powers of 10 with multiplication. So notice that we have this problem, 169 divided by 1 and 675 thousandths. So 1 and 675 thousandths, this number right here, this is not a whole number. This is a number that's in between 1 and 2, that's really close to 1.5, but it's not a whole number. So in order to be able to use an algorithm for this, we have to turn it into a whole number. So what we are going to do is we are going to take 1 and 625 thousandths, and we are going to turn it into a whole number. So what we are going to do to turn it into a whole number is we're going to multiply it by 1,000. Okay? So we're going to multiply it, here's by 10, by another 10, and by another 10, which 10 times 10 is 100, times 10 is 1,000. So in all, we ended up multiplying it by 1,000 in order to get it to be a whole number. I see some of you writing this on your notes. That's a really smart thing to do. So if we multiply our divisor by 1,000, then we have to multiply our dividend by 1,000 in order to create an equivalent problem. We have this beautiful, it's right here. This is called a ratio table, and I love ratio tables. You'll learn about my love for ratio tables later this fall. But I took my divisor, multiplied it by 1,000, and I got 1,625. So I'm going to do the same thing to my dividend. I'm going to multiply it by 1,000, and I end up with 169,000. Okay? It's sort of like I had, if I think of 169, and my decimal point is here, and I multiply it by 10, another set of 10, and another set of 10. That's how I end up with 169,000. Do you guys have any questions about that? Okay, so now I have a problem where my divisor is a whole number. And I'm going to go through all the steps that I need to take in order to be able to solve this problem. So, I'm just going to do this like long division, just like I did the problems that you guys did on the other page. So, 1,625 does not go into 1. It does not go into 16. It does not go into 169, but it does go into 1,690 one time. So we got our 1 there. I'm going to subtract 1,625, and I'm going to be left with 665, sorry. I'm now going to bring down a 0 here. Well, 1,625 does not go into 650, so I'm going to put a 0 up here. And I'm going to bring down another 0. So I now have 6,500. I'll go ahead and just tell you guys that 1,625 goes in 4 times, and it ends up being 6,500. When I subtract, I have 0 left over, so I have no remainder. So my quotient, or my answer, is 104. So there's my final answer for that. That's a situation where it ended up that I have a whole number answer at the end. I don't have to worry about my remainder. But on this next one down here, we do need to worry about our remainder. So once again, we have 51 and 66 hundredths divided by 4 and 2 tenths. Now right here we have our divisor, and it's not a whole number. We want to turn that into 42. So I'm going to multiply 4.2 times 10, which means I need to do the same thing to my dividend. So I end up with 516 and 6 tenths divided by 42. I can still have a decimal point in my dividend. That's okay. I can still have that, and that's okay. So let's talk about this problem because there's one different thing that I want you to see here. So I set up my problem here. 42 does not go into 5, but 42 does go into 51. It'll go in one time. Put my 42 here, subtract, and I'm left with 9. I'm going to bring down my 6. 42 will go into 96 2 times. And 42 times 2 is 84. I'll subtract, and I'm left with 12. I'm going to bring down my 6. I want you to notice something here, though. There is a decimal point here, so I need to put my decimal point in my quotient. It's in my answer. Make sure you do not forget to do that. 42 goes into 126 3 times, which is 126. When we subtract, we're left with 0 there. Okay, I'm going to pause this so I can answer a question. So the last problem we're going to look at today is number 1 right here. It says divide 28 and 9 tenths by 28 and 9 tenths divided by 3 and 4 tenths. So remember, we have to get our divisor. It needs to be a whole number, and 3 and 4 tenths is not a whole number. It's between 3 and 4. Do you know what we're going to do? What are we going to do?
You're going to round it to a whole number and make it less than 5
Well, we're not going to round, but we are. Do you know? Yeah. Yeah, we're going to end up multiplying this by 10. So if we multiply 3.4 by 10, we also need to multiply our dividend. So our new problem is 289 divided by 34. Okay? And that's an equivalent problem. We've multiplied both parts of this by 10, but our divisor is now a whole number. So I'm going to write this just kind of in an algorithm form here, so we can begin solving it. 34 does not go into 2, it does not go into 28, but it does go into 289. Now, what I know is that 34 times 10 is 340. So 34 times 9 is going to be just a little bit more than 300. So my guess is if I do 34 times 8, that should work, but I am going to check it over here. So 8 times 4 is 32. Help us out, guys. 8 times 3 is 24 plus 3, 24, 25, 26, 27. So I have 272. So it does go in. So I'm going to put 8 here, and 34 times 8 is 272. And when I subtract, 9 minus 2 is 7, and 8 minus 7 is 1. So I still have some left over. I still have 17 left over. I could say that my answer is 8, remainder 17. I could say that my answer is 8 and 17/34. But I'm going to put my answer as a decimal, okay? Because I want to get a little more precise here. So I'm going to bring down a 0 right here. Okay? So 34 goes into 170. I'm going to help you guys out with this one. It goes in 5 times. So I'm going to put my 5 up here. 34 times 5 is 170. and I'm left with 0. So I can stop there. So my final answer for this is 8 and 5 tenths.